Hello. So as Harsh said, for anyone who's joining on time instead of early, like I did, I'm a product manager. I'm with Thoughtworks UK, based in the London office. And I've been with Thoughtworks for just about 2 years. My background before that was pretty varied. I was in creative services. I did some technical SEO, digital marketing before I moved into product management. So all told, I've been making and growing digital products for over 10 years. And today we're going to talk about some of the inherent ways that generative AI can challenge established product practice and how we as product people can think about some of these risks. So a very loose agenda. We're going to talk about how product best practice requires good data hygiene. Our main job is to understand impact, and we need good data to do it. How generative AI challenges this, and so it challenges our understanding of product success, and then what we should do about it. So the main thesis is this, that in the development and adoption of generative AI products, traditional product practices have broken down. So generative AI products yield fundamentally different outputs from traditional products, specifically because they're designed to be indistinguishable once they're out in the wild. We actually shouldn't be able to tell the difference between synthetically generated content and content created by people. But because their output is by design unidentifiable, we don't have a way of measuring or even identifying longer term, wider ranging, externalized impacts of these products. In fact, the fact that they're impossible to identify makes it impossible for us to know when we're actually re-ingesting data that comes from other algorithms. And I wanted to talk about this today because I really haven't heard many people talking about this risk. In particular, I encourage us to look at this from a longitudinal perspective, from a perspective that recognizes we're at the beginning of many generations of algorithmic learning. We don't know how our products or the ethics of product practice may be impacted by continuing to develop at pace in the way that we have been. So I'm not here to say that generative AI is evil. I've spent the last 4 months on an AI project here in the UK, where allowing the nuances of natural language in user interactions, I think, can actually bring a more productive, even possibly more equitable experience. However, as a discipline, generative challenges the basic concept of being able to measure impact appropriately, which we shouldn't ignore. I see us as product folks as the standard bearers of digital experiences. So we need to start having some serious conversations about these sorts of products in particular. So I'm going to start by talking about some existing product practices. And this is a quick review of something that I think will be very familiar to this audience, which is the importance of isolating elements in our products when we're doing iterative learning. So we talk a lot about testing. We talk about validation of our hypotheses. We talk about using data to challenge our own biases. And because humans are fallible, we develop techniques to combat bias. We develop frameworks that are designed to help us make the least worst decision. That's how I love to think about it. And so one of these is that we isolate our variables when we test a concept. To test a new journey flow, for example, we leave the design elements alone. And if we want to test a product's desirability with a new user group, we don't alter the feature set. We do our best to keep variables we're testing clearly demarcated so that we can interpret the outcome. In short, we need to understand cause and effect, so we design our learning and feedback loops to inform next iterations in a neat, explainable way. And as I said, this is something that I expect everyone in this audience is very comfortable with. In AI as well, we've developed techniques for understanding cause and effect. And one foundational way that we manage this in traditional AI is to clearly identify and ring-fence training data. And the reason we do this is because we want our AI models to perform certain tasks. And one way we can define that is to see how well our models are able to translate the parameters on which they've been trained into new scenarios. So when it comes to training data, we select it carefully to ensure it's fit for purpose, like all these lovely bears. We want it to be sufficiently reliable. We want it to be reasonably varied without skew. We want it to be large enough. And then typically, we reserve some portion of training data to use as testing data So we keep a pool of data that is similarly reliable, varied, and large to ensure that our models are able to generalize to data points they haven't yet seen. So you can see here, you have a collection of labeled images of bears has trained a classifier model to be able to identify other images of bears that it hasn't seen before. Generative AI, however, maps data together to create things that may not have been seen explicitly in any of the training data. And here I want to credit, I believe it's Farouk in Thoughtworks Canada, whose slide I have pretty much shamelessly stolen, but I replaced dogs with bears. And this is so far so good, right? When we're building algorithms, this whole process remains within our own environments. This remains within our sphere of control. We're able to identify the training and testing data, as well as the output, as distinct groups. So if we aren't happy with the way the AI is performing, if we think it isn't serving our goals well enough, we can pause and we can adjust either the model itself or the data it's being trained and tested on. That's good hygiene, to be able to identify each of those types of data and adjust the system appropriately. However, once our model is shipped and the generative AI product is live, we lose the ability to distinguish whether any of the output is the product of an algorithm or of a human being. And that's really important. We end up with this situation. In generative, we want our models to be training on real-world behavior. So we need to know what behavior comes from humans and what is a machine's imitation. Otherwise, it's what we end up with, where we should be carefully selecting our training data to ensure it has the right qualities for a model to learn from. Instead, we risk re-ingesting the output of our models, mushing it all in with our training data set and calling it a day. And that closes the loop far too neatly on our own data. It creates a sort of sealed environment where new information can't get in, and we can't really evaluate the suitability of our models anymore. So what happens when models train using recycled output? If we don't keep testing data cleanly separated from our training data, and instead end up testing our models on the same inputs on which they were trained, models tend to overfit. And that means that they appear to be performing exceptionally well, much like if you took a history test in school that happened to only ask questions which you had been explicitly asked in class. But in that scenario, there is no creative thinking. You wouldn't need to understand the concepts behind the answers. You could memorize by rote. And this isn't what we're asking generative AI to do. We want generative to express creativity, or to use a less anthropomorphized way of saying it, we want generative AI to map concepts together in a way that we might not have seen before. Its value is in being able to discern linkages and patterns that humans may not be able to identify so easily and pull them together. So we don't want models that overfit. We don't want generative AI that only recreates what it's already seen. We want it to synthesize new information as well. But what's the problem? So perhaps no one has yet put a backpack on a bear and taken a photo, but it is possible. So what's the problem if algorithmically created content works its way into training data for new models? And perhaps nothing will go wrong, fair enough. But as product people, it's our job to be selective about the data we use because it could. So for example, enough images like that can start to bias us towards thinking that, hey, bears sure do use backpacks a lot. And that seems like a normal thing that bears do, now that I've seen so many pictures. And that sounds really silly until you realize that even real life data points can cause harm. So there are lots of examples of harm that can already be done using genuine human-generated data and experiences. Real-world data is already imperfect, and overfitting models reinforces biases that already exist in the data. Now we know what happens when we introduce bias into our products, and I don't feel that we've really solved for that problem yet. But because no AI talk is complete without a scary example of how things can go wrong, I'm going to give you 3. So the first example is generating images of doctors. Arseny Elenichev, who's a social scientist with the Oxford Johns Hopkins Global Infectious Disease Ethics Collaborative, that is a lot of words to say at once, attempted to get image generators to construct images of Black doctors treating white patients. And to quote NPR, despite his specifications, with that request, the AI program almost always depicted the children as Black. Try as they might, the team was unable to get Black doctors and white patients in one image. In fact, out of 150 images of HIV patients, 148 were Black and 2 were white. Some results put African wildlife, like giraffes and elephants, next to Black physicians. This image that I've put on the screen is actually one of the least problematic images I could have shown from that article. As a second example, this is about using facial recognition to predict professions. I bet you know where we're going with this. Last year, researchers at Johns Hopkins University and Georgia Tech asked AI to sort images of faces into boxes based on whether they were doctors, criminals, homemakers, etc. And nothing in the images themselves gave any clue as to the subject's activities. So according to the researchers, they actually expected the system to throw an error. Instead, it merrily complied, and it used racist and sexist inferences to classify people of color as criminals and janitors, and women of all races as less likely to be doctors. One of the things that the team actually cautioned about when this was coming out is that they were very concerned about the need to prevent future machines from adopting and reenacting human stereotypes. And the third example, which I think is really clear, especially when we talk about natural language processing, is about gender bias in sentence creation. So when we're transforming words and phrases and images for use in natural language processing, we'll often use a technique called embedding. And it takes all of that content and it turns it into a numerical identifier. And that's based on the historical statistical likelihood of different words, phrases, image elements, et cetera, appearing together. But I think we all know that historically, that's not an unbiased way of looking at data. And so that's led to examples like this one, which if it's a bit small on your screen, this is Google Translate replacing the Hungarian pronoun o, which is gender neutral, with he and she when translating into English. And Google Translate made that decision of which was the most appropriate pronoun based on historical phrases. So if it's too small for you to read, a bunch of gender neutral phrases were translated into she is beautiful, he is clever, he reads, she washes the dishes, etc. So I said in the beginning that it's the invisibility of generative AI's output that concerns me. Once a synthetically generated piece of content is out in the world, it's frequently impossible to identify. And if you were joined a few minutes early, I mentioned why I feel confident saying this. And it's because a few months ago, I asked a few hundred of the great technologists at Thoughtworks on a chat, what techniques, if any, could we use to mark this content so that it's identifiable after the fact? Conversely, is there a way we could fingerprint human-made content? And that's just to discern between the two. That's not to make a judgment. But really, there isn't a great way to do this. And that chat thread, the origin of this talk, I should say there are some people starting to try to do this, but obviously we are at early days in these techniques. So all AI requires inputs in the form of training data and eventually feedback loops in order to do its job. We looked at this earlier, and we know that feedback loops are a normal, necessary component of good practice. And they're actually a key indicator, certainly when I'm working with clients, of whether or not they have a data-led culture. But in a world where there's so much content being generated synthetically, the greatest violation of product best practice that I see is the risk of the snake eating its own tail. And we're probably already living in a world where the output of generative models is being ingested as input. And we need to understand and ideally measure the implications of that. So in the next couple of minutes, I want to look at how we as product people tend to look at measuring success. So traditional ways of defining measurements. As product people, we're probably well acquainted with objectives and key results, mean value trees, and other versions of strategic outcome mapping. And we tend to be concerned with defining an appropriate set of metrics that, taken together, will tell the story of whether we're meeting a standard of good enough. And I want to credit Lori Harvey for this image because I actually think this is a really good representation of the main areas of concern. Now, when we define our KPIs, we're probably also familiar with the idea of check metrics. And those are metrics that ensure we achieve our goals without causing harm to other parts of the experience or ecosystem. And so an example would be, we can focus on growth as long as we don't damage retention, or we can focus on speed only if we can maintain quality. But we rarely, if ever, consider the success of our product in relationship with the well-being of those outside our target user audience. So I am now going to gunk up Lori's pretty image. I feel that traditional ways of establishing metrics generally blinkers our thinking because even the best practice methods only start at the company level. We're never asked to look outside our organization's immediate needs or occasionally the needs of partners or regulators. So we generally end up ignoring all the folks who don't actively use our products and who haven't consented to engage with us, even if they risk being impacted. Now, this may seem totally reasonable. After all, our organizations are who we work for, and the traditional product manager archetype is defined as a set of competencies that asks us to have a degree of practitioner skill across tech, business, and design. But I actually really challenge this model because over the years, as I've trained other product people, I started finding it more accurate and meaningful to define the product manager role as one of stewardship, where we're responsible for negotiating a way to meet the needs of our business, our customer, the wider market, and non-users. That is a significantly wider net, and it's a mental model that I find more useful day to day in my work. The inclusion of non-users is really important because it's the impact to them that can be the hardest for us to think through. It's really hard to anticipate and risk model. And that's because the effects might be longer term, they might come in unanticipated forms, but mostly we simply aren't incentivized to care about them. However, if we start to include non-users among the points of view that we need to consider, then that's not only, I would say, the ethical thing to do, but it's also more economically efficient because harm done to these people currently represents a negative externality or unintended damage for which we and our organizations do not incur a cost, but probably should. When we include non-users' needs within our sphere of responsibility, it means harm to them is no longer external to our responsibilities, and rather we consider harm reduction and remediation as part of our product and we cost it appropriately. Remember, I said this is one of the less problematic images I could have shown in the failed experiment to show Black doctors treating white patients. This image is not real. Now, I'm sure there are white doctors treating Black patients, albeit perhaps with less of a halo, and hopefully in an actual medical setting. But this image is not real. Not only is it not real, it completely failed to meet the demands of the prompt. So I'm pretty confident that the product manager would consider this a failure. But now it's out there in the world, and it doesn't take much to remove the fake label and send it back out. So for me, that's the core issue. For all the other things this image may be, it is also an example of a failure, but it risks being re-ingested by any number of other image generation tools as training data. And as training data, it becomes the guide for future product behavior. I don't think I can say this enough, that this does not meet appropriate product quality standards, but it may be taken in to train future models. And of course, because it perpetuates stereotypes, that to me is a pretty painful example of a negative externality on non-users. A lot of people can be hurt by images like this, who never consented to engage with the image generation AI in the first place. And I think we owe those people better than this. So to reiterate from earlier, the output of generative AI products can be impossible to identify once it's out in the world. And that leads to challenges in product data hygiene when we accidentally train new models on machine-made or poor quality content. And this comes with a series of risks which we don't fully understand or have established practices to mitigate. Not to mention the fact that many harms may be outside the context that we're observing and measuring. So, what can we do? Here I want to offer a few concrete steps you can take if you're developing AI products. This list will not be exhaustive. I want to be very clear on that, but I do encourage folks to reach out if you're interested in learning more, because I think this is a really important area. We should be supporting each other to learn as we go. And the first area I want to talk about is data diligence. So recently, MIT and some of their partners audited more than 1,800 frequently used training data sets. And they released their Data Provenance Explorer tool just last month. And this is to help anyone who's building AI products, particularly generative, identify the origins of their data and determine whether it's fit for purpose. So that's great. We can start to audit our data better. Now, there are also ways that you can ensure your products don't add to training data sets inappropriately. So far, I generally hear these mentioned as a way to protect IP or to lower competitive pressure. But I think as product people, we should also consider these tools for stewarding data quality for the future. This is a quickly evolving arena. I want to be really clear. There is not comprehensive governance on how to remove yourself from LLMs and other large data sets. So the list I've linked to here, it's some mechanisms for opting out, but I really want to say you'd have to independently assess your options as well. Second area where we can actually take some actions is about building in non-users when we consider our products. And two pretty concrete tools that we already have in our toolkit. One is assumption mapping. And I recommend doing assumption mapping with an explicit non-users or called here bystanders. I'm not going to go into the details of assumption mapping here. I'm sure you're already familiar with it. I provided a link to an explainer. But I find that a neat trick, if you want to turn assumption mapping into more explicit risk mapping, is to frame the prompt as, how could our product fail? And that nudges teams to consider more potential downsides, where I find that traditional assumption mapping is a bit more optimistically oriented usually. If you've done that, then it becomes pretty straightforward to identify check metrics that consider those people's well-being. And the article linked there, it's an oldie but a goodie. It's from 2017. But in my opinion, it's a really good basic explainer of what check metrics are and why they matter. So if you're not familiar with working with them, highly recommend. And a third arena, which feels pretty important as this becomes such a dominant technological theme, is about supporting relevant regulation and governance. And maybe not everyone here is a fan of heavy regulation. That's okay. Bear with me for a sec. So as we speak, the EU Artificial Intelligence Act is being developed and debated. Fair warning, the links here may already be out of date. However, we've seen previously with GDPR how technology regulation in Europe can drive worldwide behavior. And however you feel about the individual provisions in the Act, the scale of international cooperation that we're beginning to see in this space is worth paying attention to. I should note there is a possibility of some technologies, I believe ChatGPT is one of them, being exempt, so it's not a silver bullet. And the last piece here is a policy framework from the Center for Humane Technology. And I wanted to reference it, even though it's not specific to AI, because it provides a pretty comprehensive way of thinking about implementing regulation. And while people in this audience may not be politicians and regulators themselves, I actually also find it as a useful reference point if I'm creating internal governance within an organization. So yeah, that's where I'm going to leave it for today. Thank you so much, everyone, for your time.